Asynchronous programming continues to gain traction over synchronous programming in specific areas. One of those areas that asynchronous programming proves superior over synchronous programming is web scraping. Now, in this video, we're going to be scraping the same site using synchronous programming and asynchronous programming and see the time benefits that asynchronous programming brings onto the table of asynchronous programming and what Python libraries you need to use in case you want to integrate asynchronous programming into your web scraping workflow. So without further ado, let's get started. Alright guys, so I've switched the folder that we're going to be using for this video. In this folder, I have the main.py file and a script virtual environment. Okay, inside the virtual environment is where we're going to install all the libraries that we need. The website that we're going to be using for this video, we're going to be using the Books to Scrape website. It's a great choice for educational purposes. If you're learning web scraping, it's a great choice. And because this is an educational video, we're going to be using this website. What we're going to be doing is we're going to be scraping all the books available in the Books to Scrape website. And we are going to store these books in a .json file, okay? As you can see, we have a total of 1,000 books. And these books have been spanned across a total of 50 pages. So basically, we're going to be scraping all the 50 pages synchronously, and then later on, we're going to scrape these pages asynchronously. So to scrape a website synchronously, we are going to be using two libraries, BeautifulSoup and Selenium. So Selenium is going to get the details, is going to get the page source for us, and then we're going to be using BS4 or BeautifulSoup to actually locate the root element. That is the root element that contains all the books, and get each book and get the details of each book. Then once we get the details of each book, we're going to store the details in a .json file. So let's start with synchronous programming. So I'll just say synchron programming. And then the libraries that you're going to be using is BeautifulSoup and Selenium, okay? Now that we have that set, so the first thing we're going to do is get the URL of the ToScrape website. So let me just expand that. So I'll copy the URL and then create a variable and store that URL in it as a list. Okay, and then next, like I said, you're going to be using Selenium to actually get the page source and then pass that page source to BeautifulSoup and then scrape the details of each book. So to do that, I'm going to import Selenium. I'll say from Selenium, we're going to be using the Chrome WebDriver, .WebDriver import Chrome. Okay, and for passing the HTML, we are going to be using BeautifulSoup. So I'll say from BS4 import the BeautifulSoup class. Okay, now the next step we are going to do is, because we have more than one page, the best way to do this is to use a while loop. Okay, so I will create a while. First, I will create a driver and I will create that and I'll set that to an instance of the Chrome class. And then I will say driver.get the page source. That is the URL. And then from this, we can now get the page source of we can actually get the page source of each page. But because we'll be scraping more than one page, I want to nest the logic for scraping each page inside a while loop. So I'll say while true, we're going to get the page source. So I'll say page source equals to driver.page source. Okay, remember, as we go through each page, we are getting a new page source, right? So we want to be able to get each page source within the while loop. And then I'm going to create a soup that is an instance of the BeautifulSoup class equals to BeautifulSoup. And then I'm going to pass in the page source. And apart from passing in the page source, I'm going to use the default parser, which is html.parser. Okay, and just like that, we have the HTML. Okay. Now that we have the HTML, the next step is to find the root element. Now, if we switch back to the Books to Scrape website, to be able to locate the root element, that not basically the root element, but the parent element that contains all the books, what we are going to do, we are going to right click and click on inspect. And then with inspect, we're going to hover over the source code or the page source and find and locate the parent element that contains all the books. So to do that, I'm just going to hover over all these details. And as you can see, the section is the parent element. And specifically, inside the OL. Yeah, so the OL is the parent element, and then inside this OL we have LIs, LI elements that contain the actual details of the book. So we need to get this OL element. So to do that, we're going to be using BeautifulSoup find method, and then we're going to find the element OL with the class set to row. So I'll just copy the row, the class row, and then I will say that the root element in this case is soup.find an OL element with a class of row. So I'm using class with a leading underscore because we don't want this class argument to conflict with the class statement that is defined in Python's standard library, right? And then now that we have the root element, now we can get all the LIs. So to do that, you're going to say LIs equals to root dot find all. Now the find all method returns a list. So we want to find all the LIs. If I go back here, you'll notice that all the LIs have the same class, right? So there's really no point for me to be more specific by specifying the class name. But if you're working with a website that maybe all the LIs share classes with other elements, what you can do, you can be more specific by specifying what is the class name of the target element, in this case LIs, for whatever website that you're scraping. Now that we have all the LIs, we want to go through each LI and pass each LI to find the details of the book, or the details of each book. Now you'll notice that the details of the book are nested inside the article element with the class product pod, right? And then in here we have a heading 3 which contains the title. Actually, the heading 3 nests another A tag with 2 attributes, href for the link and title attribute for the title of the book. So this is what we want, the heading 3. And then for the price and the stock availability, we are going to target a div with the class product price, right? And then in here, we're going to find the 2 paragraphs. So one with the class price color contains the price of the book, and another paragraph with the class in stock availability contains the availability of stock. Now for the first book, it is in stock, so that is what we want to get. So to do that, we're going to go through each LI and get the article element, because this is the nesting element that contains the nesting element for all the details that we need. So to do that, I'm going to use a for loop. I'll say for each LI in LIs, right? We're going to find the container, which is in this case is each.find. Now each in this case represents as an individual LI element. If we go back here, each in this case represents a single LI, right? So through the loop, we're going to be looping through all the LI elements and get the LI, and then inside that LI, we are finding the article element. I hope that is clear. So going back, I will say find an element with the name article, find the article element, and it has a class of product pod, I think. Yeah, product pod, right? And then inside this container, now we can target the rest of the elements. So for title, for the link and the title of the book, we're going to target the heading 3 and the A tag. So to do that, I will say let's get the heading 3, which is still inside the container. Let's find a heading 3 element, right? And find an A tag, because the A tag is nested inside the heading 3. I hope that is clear. So we'll get the href and the title for that. So to do that, to get the title, I will say title equals to heading 3, and then passing the attribute that we want to find. In this case is the title attribute. And then for the link, we are going to say heading 3 also, and then what attribute? The href attribute. And just like that, we have the title of the book and the href, and we have the title of the book and we have the link to that specific book. Next, we want to find the title we want to find the price and the stock availability. To do that, we are going to get another container, which is another div with a class product price. So I'll copy that class, and then I will say, I can just say price container is each, right? Remember, this price container, this product price div is inside the article element, right? Is inside the article element, and we have the article element right here. So we'll say price cont is container.find, right? we're going to find a div with a class set to product price, right? And then inside this product price, we're going to find the two paragraphs. So we will find the first paragraph that contains the price. I'll say price is equals to price container dot find a paragraph with a class. Let's get the class of this of the paragraph that contains the price. It's price color. So I'll copy that and then I'll paste it in right here. And then use the text attribute to get the value that is nested inside this p tag, okay? And then next, apart from the price, we're going to get the availability. So I'll create another variable, call it availability. And then I'll set it to price container dot find. We're going to find another p tag, but in this case, it has a value. The class for the paragraph that contains the in stock availability has a class of in stock availability. So I'll copy that and I'll paste it in and use the text attribute to find the value that is nested inside of it. And just like that, we have all the four values that we need: the title, the link, the price, and the availability. Now that we have all of these values, the next logical step is to store these values or this data in a data structure. Now, the data structure of choice for this, we're going to be using a dictionary. So I'll create a dictionary, call it a data dict, right? And then this data dict is going to have 4 keys which correspond to the 4 values that we have. So I will say data dict, the first key is going to be the title, equals to the title of the book. Data dict dot link of the book to the book is going to be the link, and then we will say data dict dot price equals to the price, and finally data dict dot availability, I'll set that to availability, okay? And then because we are scraping through many pages, right? Because we're scraping through 50 pages, we're scraping the first page, going to the second page, all the way to page 50. We want to be able to store this data because in the first page, once we scrape the first page, we're going to go through the for loop, right? Once we scrape the second page, you're also going to go through the for loop. Now, through each page, you want to be able to store this data dictionary data, this data data, right? So to do that, I'm going to create a list. I'll call it book list equals to an empty list, and then we are going to append each data dict inside this list. So I'll say book list dot append data dictionary, okay, this data dictionary. And then after we have scraped the first page, we want to go to the next page. So to be able to go to the next page, we are going to be using the by class so that we can target the next button and then use Selenium to click on that next button. So if I scroll to the end of the page, you'll notice that we have a next button. So let's inspect this button. You'll notice that it is an A tag that is nested inside an li element with a class next. So we want to find the li element and then find the A tag that is nested inside this li element. So to do that, we are going to first import by. So I will say from selenium.webdriver.common, we're going to .common.by. We are going to import the by class. And then what you're going to do is we are going to nest the next logic inside a try and except block. And why am I saying that? Is because Selenium will continuously find the next btn and click on it. And once we get to page 50, so let me just go to the page 50. Let me go to next. And then after next, let me just edit the URL and enter 50 because we have 50 pages. You'll notice that on page 50, we don't have the next button, right? So of course, Selenium will try to find it, but then because it won't find it, it's going to raise an exception. So we want to be able to capture that exception within the except block. So I will create a try block, and then we are going to find the btn. We're going to say driver.find element. We're going to be using the by.xpath, and then I'm going to pass in the xpath. Now in this case, our next button, let me go back to page 1. Right, so page 1, we want to find the li element with the class next, and then find the a tag. So to do that, we're going to say xpath equal to, it's an li element, right, with the class is set to next. And then after finding that, we're going to find an a tag, right? And then after finding that, we're going to click on that so that we can go to the next page. Click on that so that you can go to the next page. And then after going to the next page, if we get to page 50, we are not going to have the btn next. So we are going to capture, we want to be able to handle that exception. So we'll say exception. We can just say except, and then we are going to break from the while loop. That means we have reached the final page, right? And then after we have scraped all the pages, we want to be able to see the time that it takes to scrape all the 50 pages so that we can compare that time to scraping the same page using asynchronous programming. And then also we want to store this book list within in a .json file. So I'm going to import two libraries. I'm going to say import JSON, and I'm also going to import time, right? So we are going to start timing this while loop once we enter into the while loop. So I will say start time, set that to time.perform counter, and then we can say end time equals to time.perform, let's say time.perform counter, subtract the start time. Okay, but before we do, we actually calculate the total time it takes. We want to store this data, all the books data, inside a .json file. So to do that, we're going to be using the with context manager. I will say with open, I can type that correctly. I'll say data underscore, let's call it a book data. Let's give it a name, book data.json, and then we're going to write to it as file, and then we can say json.dump the book list inside the file. Okay, so if the open context manager doesn't find a file with the name book data.json, what's going to happen is going to create a new book. But because we're also going to create another file for asynchronous programming, let's call it book data sy, right, for synchronous, and then ay for asynchronous later on. And then, yeah, that is it. So another thing we're going to do, we want to be able to just, because I want to set this to headless, or let's not really set that to headless. So let's just run our code and see what we are getting. So I will say python3 main.py. So it's going to open the first page, and then it's going to go to the second page. So I want you to keep an eye on the URL. As you can see, we are at page 6, page 7, all the way to page 50, and then it's going to take all the information scraped, store it in a .json file, and then give us the end time that it takes. Oh, I forgot to really actually print the end time. So let me cancel that, and then we'll come back to that in a second. I will say print total time to scrape the 50 pages is, let's use f strings for this. So I'll pass in an f, and then the end time, because it's in seconds, let me round it off to 3 decimal places. So I'll say 3f, and then set that to seconds. So let's run that again so that we can actually get the time that it takes to scrape all the 50 pages. Enter. So yeah. So I want you to really keep an eye on the URL. As you can see, we are on page 5 and then page 6. So it's just going to do that continuously until you get to the end of the page, where we are no longer going to have the next btn, and then it's going to exit and break from the while loop, store that information in a book list, and then we're going to copy that information from the book list and store it in a book underscore data underscore sy.json. Okay, so let's wait for the pages, for all the 50 pages to be scraped. Amazing. So we have all the 50 pages scraped, and as you can see on the terminal, we are told that total time to scrape the 50 pages is 83.884 seconds. Now I want us to do the calculation for what it takes to calculate a single page. So I'll say 83.884. I'll divide that by 50. And yeah, it takes about 1.7 seconds to scrape a single page. Okay, so you can imagine how that would scale if you're scraping a total of maybe 100 pages, it would really take a lot of time. Now, for instance, let's say you're scraping 1,000 pages, right? If it takes 1.7 seconds to scrape one page, if you had 1,000 pages, it would take 1,700 seconds. Now, if I divide that by 60 to get that in minutes, that would be 28 minutes. I mean, we're talking about probably 30 minutes, right? So that is a long time. Now, we want to script the same page using asynchronous programming. So let's do that. So what I'm going to do, let me just open the book data.json. And as you can see, we have all the book data stored inside the JSON file. You can see that each data takes a total of how many new spaces? We have 1, 2, 3, 4, 5, 6. And we have 6,000 books, 6,000 lines. So if I say 6,000 divided by 6, we get 1,000. That means we have 1,000 books, which corresponds to all the books from the books to scrape website. Now, I want us to scrape the same website using asynchronous programming. So I'll just comment out everything except time and JSON, because we're going to be using that again, right? And then remember, we also copy this block of code. We don't have to write it again, because we're going to reuse it to get the data for each book inside each page. Now, for asynchronous programming, we're going to be using two libraries. We are going to be using asyncio. So asyncio basically means asynchronous input-output. And then we're also going to be using aiohttp. Okay, so these are the libraries you're going to be using for asynchronous programming. Let me just comment that out. Let me also include that comment. I can type synchronous programming. Yeah. So let's get started with asynchronous programming. Now, when you're working with asynchronous programming, you always want to have an event loop, okay? The main event loop. Now, the main event loop is what is going to handle all the coroutines that you're going to use, because we're not just going to be using a single coroutine. Now, we have 50 pages in the books to scrape website. What you're going to do, we're going to create 50 coroutines, right? Each coroutine is going to scrape each page. And then from that, we're going to collect that data, store it in a book.json, maybe collect that information, store it in a list, and then later on write it to our .json file, just like we did with the synchronous programming. So to do that, I'm going to create our main loop. I will say we're going to be using the async keyword to show that this is a coroutine, because asyncio, the event loop, requires a coroutine. It cannot run, you cannot pass a normal function inside the event loop of asyncio. So I'll say async and then def main. Now inside here is where we are now going to create an instance of the aiohttp client session. So I will import aiohttp. So import aiohttp. Well, aiohttp. So if you don't have it, just say pip install aiohttp, and also import asyncio. So the two libraries that you're going to be using for asynchronous programming. Press enter. I already have them installed. That's why I'm getting requirement already satisfied. If you don't have them, just make sure you install them so that you can follow comfortably. And then after that, we are going to create a client session. So I will also use async with. Okay, the context manager for this is not with, it is async with, because we are working with asynchronous programming. So I'll say with aiohttp.client session, okay, as session. What you're going to do now, we're going to create all the coroutines that you need. Now first, because we don't have the coroutines, let's create them. Remember, a coroutine requires you to it's defined using the async keyword. So I'll say def and then get. Let's create a new function or a new coroutine called get page data. Okay, now this page data is going to take as the session, in this case aiohttp.client session, okay, and a URL, which in this case is a string, right? Type hinting, very important. And then inside here, what we are going to do, we are also going to say async with, okay? Oh, sorry, you're going to say async with with session.get. We are going to pass in the URL as page, And then we want to get now the page source, which is in HTML form, right? So I can say results equals to await. Now the await keyword is very important because what it does basically, it's going to stop the execution of anything that follows in the get page data function. It's going to stop. It's almost like when you use time.sleep, right? You're going to pause execution of everything that is below the time.sleep, right? Just the same way when you use await, you're going to pause everything that comes after this line of code. So I'll say results, await, and then we can say page.text. Okay, so we want to wait for the results to come so that we can delegate it to the next function. Now, the next function that you're going to create now is going to scrape the data from that single page. Okay, so basically, this coroutine gets the data for a single page, and we are going to be creating 50 coroutines to correspond to the 50 pages that we have. Now, once we get the details or the page source of the from each page, we want to delegate these results to another function that's now going to scrape the data for us. Now, what we're going to do, we are going to create that function. So this is just a normal function. It doesn't have to be a coroutine because it's what we call for instance, the async def get page data. It's an IO bound process. Okay, it's an input output bound function. But then when you are scraping the data, because now the data has already been received, it's going to be process bound. So it's basically process bound. It's not input output bound. I hope that is clear. So I will say scrape data, create a new function, call it scrape data. So it's going to take HTML, which in this case is provided to you as a string. Let's just confirm that. Let me say pass. And then if we look at the text, if I hover over this, it returns a coroutine any or string. So it returns a string basically, right? So yeah, so that is HTML. Now this is what, now we are going to pass in the result to the script data. And then in here now, what we are going to do, we want to use a list. So I'll first create a list. I'll say data list. So it's basically going to hold the information of all the pages that we, for all the books in a single page. And then I'm just going to copy the entirety of this. Okay, so I'll just copy from this to this. So I'll copy that and then I'll just paste it in here. Then I'll comment out everything. So I'll press Control and then / to comment out everything. Oh, we also need we also need BeautifulSoup. So I'll just comment out BeautifulSoup because we need it like that. And then, yeah, so, and then I'll replace page source with the HTML, right? And then after getting all the data for each book, we want to be able to append it to the data list. So I will say data list dot append data dictionary, okay? And just like that, we have appended all the book information for each page inside the data list. And then we can finally return the data list, okay? Not data date, well, data list, okay? So we have the list of books in a single page. So we can pass it here. We can say return get, it is page data. No, it is scrape. Oh, I named it scrape. My bad. So I'll say scrape and then scrape. Nice. And then scrape and then return the results. With that, we have now created a coroutine, and then we want to create a total of 50 coroutines to correspond to the 50 pages, right? So to do that, what we're going to do, we're going to be using list comprehension. So I'll say coroutines equals to a list of all the pages. Now, if I switch back to the books to scrape website, you'll notice that all the URLs are the same, except that the page number differs. So if I say 2, that is page 2. If I say page 50, we get page 50. But if I say page 51, we should get a 404 error, right? Yeah. So we're getting a 404 error. So there's no page 51. So the final page is page 50. We are going to create a list comprehension for all the 50 pages. So I'll copy that And then I will say coroutine. Let's first create all the 50 URLs. So I will come up here and then I'll say URLs equals to that. I'll paste it in, paste what we have copied from the books to scrap website, use f strings, and then instead of 50, I'll set that to I, and then we're going to use the range function. So let's say for I in range. So we're starting from page 1 to 50. So I'll set that to 51 because the range function takes the start inclusive and end exclusive bond to all the 50 pages that we need. And then what we're going to do, we are now going to create the 50 coroutines. We are going to be using asyncio methods. Now asyncio provides you with 3 methods. We have gather, we have as completed, and then we have wait. Now the difference between as completed, gather, and wait is that wait is deterministic and it allows you to actually get the results. Okay, as completed allows you to get the results, but it is non-deterministic. Gather allows you to get doesn't allow you to get the results, but it is deterministic. Okay, so but we want to be able to, we want to get the best of both worlds, determinism, and we also want to get the results. So to do that, I'm going to be using wait instead of gather and as completed. Now wait requires that the coroutines are wrapped as tasks. Okay, so we need to wrap each coroutine as a task. So to do that, we're going to import asyncio. So I'll say import asyncio, asyncio, like that, and then we are going to create now the task. We're going to take all the coroutines and wrap them inside of tasks. So I will say asyncio dot create a task, create task, and then we are going to paste our coroutine, which is get page data, right? So get page data takes a session which we have created using aiohtp client session, and then it takes a URL. So we'll say URL for URL in URLs. So basically all the URLs in here. And just like that, we have created all the coroutines. And then next, we are going to be using the, as I have said, we are going to be using the wait method. So we'll say done and pending, but we're going to be using the return when default value, which is all completed. So done is going to wait for all the coroutines to complete before it returns. Okay, so that means we are going to await. So we are going to stop any execution of anything that follows this line of code on line 84, and then we're going to pause execution until what we have in line 84 completes. So we are going to say await asyncio dot wait. Okay, so I'm going to pass in the coroutines, and you can see that return when by default here is set to all completed. So you can also set that to first completed or first exception. So first completed is the moment the first results are returned, you're going to get them in the done, and then the rest of the results are going to be held here. So you can set this to pending, right? If you have return when set to first completed or first exception, but we're just going to wait for all the results to complete and then use those results. Okay, so I'm just going to set this to an underscore because pending list is going to be empty, and then I'm just going to get rid of this because by default return when is set to all completed, and that is what we need. Asyncio.wait returns a list. Okay, so it returns a list, and then each element inside that list has a results method, which now gives you the actual results. And as you can see, what we are returning here is a list, right? We're returning a list. So what we can do, we can create a book list now, a major book list in this case. And then inside this book list, we're going to extend it using all the results we get for all the coroutines or tasks in this case. So I will say, using a for loop, I'll say for book in done, basically for each book in done, what you're going to do, we're going to say book list dot extend because it returns a list, right? So we are going to extend the book dot result, and just like that, now we can be able to extract or get the results for each page. And then once that is done, we can now write that to a .json file. So we'll say with open, right? Book, let's call it book data underscore ay for asynchronous.json. Let's use write again as file, what you're going to do is say json.dump booklist to file. Okay. Again, now let's calculate the execution time for this. So to do that, I will create a start time. Let me just copy what we had initially. So start time is this, perform counter. I'll just paste it in here because this is where our function begins. And then end time, let me do the same, end time, and then this. Bang. So let me copy that and paste it in after the with context manager. And then, yeah. So we have that. So we will get the end time, or basically the total time it takes to scrape all the 50 pages asynchronously. After creating that, we need to create the actual event loop. So to do that, I'll say if the name equals to main, right? I will say asyncio dot run. So run takes one coroutine, and we have the main as the single coroutine, which subsequently runs the rest of the coroutines. We have 50 coroutines in this case. So I'll pass main in it, and just like that, we have written the code required for scraping the same page asynchronously. Now let's run that to see what we're getting. So I will say Python 3 main.py. Bam. Amazing. There we have it, guys. So it takes 3 seconds to scrape 50 pages. Initially, we scraped the pages. It took about 78 seconds to scrape the 50 pages using asynchronous programming. But if you scrape the same pages using asynchronous programming, you get like this is over 100% performance benefits, right? So that means moving forward, if you have to scrape your pages or if you have to do any web scraping, I would suggest using asynchronous programming over synchronous programming. Okay, so if I open the book data asynchronous.json and to see the details that we have in here, you'll notice that we have a total of 602, right? Which is the same as the kind of details that we scraped using synchronous programming. So yeah, I hope you learned something in this video. If you did, let me know what your thoughts are in the comment section below. If you found this video useful, leave a like and I'll see you in the next. Bye.